So what we're looking at here is something called the power rule for finding derivatives. So the key with power rule is to keep in mind when you can use it. And power rule is only going to apply to power functions. So in arbitrary terms, this is something like f of x equals some real number value a times x to the nth power, where n represents any sort of real number. So this could be things like 1/2 equals g of x equals 1/2 times x to the negative second power, f of x equals 2x squared, or h of x equals 3 times the square root of x, which keep in mind you can rewrite radicals as fractional exponents. So take the value that x is being raised to and put it in the numerator, and then whatever your root is going to go in the bottom. So keep in mind exponents are like trees, the root goes in the bottom. So you could rewrite 3 square roots of x as 3 times x to the 1/2. So whenever you're finding the power rule of a function, what you're doing is you're taking something like this, f of x equals x to the nth power. You're simply going to drop the exponent down, so bring the exponent out in front, and then subtract 1 from the exponent. Or maybe you have a constant being multiplied by your power function in the case of g of x equals a times x to the nth power. Whenever you go to take the derivative, g prime of x is going to equal n times a to the times x to the n minus 1. So you're simply taking the exponent and putting it in front, and then subtracting 1 from the exponent. So let's look at a few examples. What we have here is f of x equals x to the third. So if I want to find the derivative f prime of x, what I'm going to do is take my 3, and I'm going to bring it out in front. So I just drop the exponent down, and then I'm going to have x to the 3 minus 1. This gives me 3 times x to the second power. So the derivative of x cubed is 3x squared. In the case of g of x, what I can do is I can rewrite this as a power function. So you can rewrite radicals as fractional exponents. In this case, I have x to the 1/2 power. Notice that the radical is the square root, so the power of x is 1, and then the root is 2, so it goes in the denominator of my fraction. Whenever I go to find the derivative, g prime of x, I have x to the 1/2 power, so I drop the 1/2 down, and then I'm going to subtract 1 from the exponent, so 1/2 minus 1 is negative 1/2. So the result here is 1/2 x to the negative 1/2. If I wanted to, I could simplify this, and this is going to give me 1 divided by 2 times the square root of x. So I'm taking my 1/2 and rewriting it as 1 divided by 2. And then x to the negative 1/2, I put that in the denominator, and then I change my fractional exponent back to a radical. Some other examples might be 3 divided by x squared. I could rewrite this as a power function. So I'll have 3 times x to the negative 2. My derivative then, f prime of x by power rule, I take the negative 2 and bring it down. Negative 2 times 3 is negative 6, x to the negative 3. So I'm taking negative 2, multiplying it by 3. So negative 2 times 3 is negative 6. And then I'm going to subtract 1 from my exponent. Negative 2 minus 1 is negative 3. In the case of g of x equals 5 times x to the 3/2, g prime of x is equal to 3/2 times 5. So I'll bring the 3/2 down, and I have 5x. 3/2 minus 1 is 1/2. So this is going to give me 15 over 2 x to the 1/2. And like we did before, I could also rewrite this as my fractional exponent as a radical if I wanted to. But unless it says simplify or get rid of your radical, this is a perfectly acceptable answer. So remember, it's g prime of x equals that. So this is power rule. It's very straightforward. All you're doing is you're taking the exponent, putting it in front of your variable, and then subtracting 1 from the exponent. The big thing to keep in mind is simply only use power rule for power functions. So x raised to a real number power. This is not going to work for exponentials. This will not work for trig functions or quotient functions or product functions. We're going to have other rules that apply to those.